What if I told you time travel is real and you've already done it? Not the sci-fi kind with DeLoreans, but the kind Einstein proved. Today, what physics actually allows, what it probably forbids, and where the loopholes might be hiding. Part 1. The kind of time travel we've already tested. First, the boring miracle, time dilation. Move fast or sit deep in gravity and your clock runs slower than mine. This isn't theory. Airplane and satellite clocks tick differently. Your phone's GPS only works because engineers correct for both speed and gravity effects. Astronauts on the ISS age a tiny bit less than we do. That's time travel to the future. You jump ahead by experiencing a little less time than everyone else. Part 2. The dream. Going backward. Backward time travel is where things get weird. General relativity's equations are so flexible that, on paper, you can curve space-time into loops called closed timelike curves, paths that let you return to your own past. 3 famous ideas show up in textbooks. Wormholes, hypothetical tunnels connecting distant regions. If you take one mouth on a fast trip or park it in strong gravity, the 2 ends can become time-shifted. Step in one mouth and step out earlier from the other. Cosmic strings, ultra-dense, line-like defects in space-time. In some arrangements, zooming around them could let you arrive before you left. The Tipler cylinder, a ridiculously long, rapidly spinning cylinder that drags space-time around with it. In theory, the right trajectory gets you a loop in time. They're spectacular on paper, but are they physical? Part 3. The price tag, exotic matter and impossible engineering. All 3 ideas run into brutal costs. Traversable wormholes seem to require negative energy, a kind of exotic matter that holds the throat open against collapse. Quantum physics lets tiny negative energy effects appear in special setups. Think Casimir effect, but not in the huge, sustained amounts a human-sized wormhole would need, at least not with anything we know how to build. Cosmic strings. We've never seen evidence for them, and the Tipler cylinder demands an object longer than most galaxies, spinning near light speed, with materials that don't exist. So while general relativity permits backward time travel in the math, the engineering bill looks impossible. And that's before we hit the logical landmines. Part 4. Paradoxes and proposed fixes. You've heard the classics. The grandfather paradox. Go back, prevent your grandparents from meeting, erase your own existence. Or the bootstrap paradox. An object or idea with no origin, like handing Shakespeare a copy of Hamlet and becoming the source of the play yourself. Physics has sketched 2 main escape routes. Novikov, self-consistency principle. Events on a closed timelike curve are self-consistent. You can try to change the past, but the only outcomes that occur are the ones that keep history intact. Maybe your scheme to stop your grandparents always fails for ordinary reasons. No contradictions, just constrained outcomes. Many worlds branching. Your trip spawns or connects to a different branch of reality. You can change a past, just not the past of the branch you came from. No paradox, but also no erasing your own timeline. Both pictures avoid contradictions. Neither has experimental confirmation for macroscopic trips. They're signposts, not solutions. Part 5. Hawking's warning label. Stephen Hawking proposed chronology protection. The laws of physics conspire to prevent time machines from forming. Perhaps by quantum effects blowing up right when a time loop would appear. We don't have a proof, but it fits a pattern. Every time we find a clever space-time that allows loops, something, exotic energy requirements, instability, quantum back reaction seems poised to slam the door. Part 6. What quantum theory whispers? Quantum mechanics adds its own rules. You can't clone unknown quantum states, you can't signal faster than light, and measurement outcomes are probabilistic. Some toy models of post-selected quantum mechanics let you compute self-consistent histories, handy for paradox-free time loop puzzles, but they don't give you a recipe for a real machine. Entanglement lets correlations stretch across distance, not messages into the past. Part 7. So, can we build a time machine? Here's the honest status. Forward travel. Absolutely, by going fast or sitting in strong gravity. It's tiny in everyday life, but it's real and measured. Backwards travel. The math allows it in special space-time. The physics we've tested strongly suggests nature prevents it by demanding exotic matter, triggering instabilities, or enforcing self-consistency. But the chase is valuable. The hunt for time machines forces us to confront the edges of quantum gravity, the still unfinished unification of general relativity and quantum mechanics. Along the way, we've learned how GPS works, how black holes store information, and how causality threads through the equations. Part 8. What would actually count as evidence? If you want a falsifiable path forward, here's what discoveries might move the needle. Clear cosmic string signatures in the sky. Laboratory evidence of stable macroscopic negative energy far beyond tiny quantum effects. A consistent theory of quantum gravity that predicts traversable, stable wormholes we could, in principle, engineer, and shows how to avoid paradoxes. We're not there, but that's the bar. Time travel isn't a yes or no, it's a spectrum. The future is open. Go fast, go high, and you really do arrive slightly ahead of everyone else. The past is guarded by energy conditions, quantum rules, and maybe the universe's own instinct for consistency. If you want more than sci-fluff, how wormholes would actually need to work, how negative energy shows up in quantum fields, and whether many worlds really saves causality, tell me which thread to pull next. Subscribe for daily scientific explainers.